So we're going to give this homeowner the soundproofing of a detached house. Now I know that's a bold claim, but stay with me to the end because I will show you the type of sound insulation materials that we're going to install to that wall and all the indirect noise paths, and you'll see what I mean. How to soundproof a room. Here we are in a 3-bed semi-detached house, and our client is suffering from noise from neighbours. They're hearing TV, conversation, they're hearing music, and when they're sleeping in this back bedroom, they're actually hearing the noise come up at an angle from the neighbour's lounge down there, diagonally down below. So what we're going to do is we're going to install sound insulation to this back bedroom and the room, the other side of this separating wall between the front and back bedroom. About 2 years ago, we soundproofed the downstairs for this property. We actually soundproofed the lounge and living room downstairs. And now here, phase 2, we're soundproofing the upstairs. So the sound insulation we're going to use to this room, we're going to install the same soundproofing materials, the same systems that we use downstairs in the living room downstairs. We're going to install it to this separating party wall and all the indirect noise paths as well. So we're going to give this homeowner the soundproofing of a detached house. Also, in this video, I want to share with you a little secret. It is something the soundproofing industry just doesn't quite get yet. I'm going to share with you that secret. It's something that we find as installers, soundproofing thousands of properties across the UK. I'm going to share with you a little secret that shows you why we get such a good reduction in noise. So to follow the 4-step soundproofing method for this room, we need to address the main cause of the problem, and that is the loft up there. That means it doesn't matter what soundproofing we do, it doesn't matter how singing or dancing the clip or wall system is to this direct noise path of the separating party wall, unless we address the loft, the noise will still come through. You'll be still in this room thinking, I still hear the noise. Next, we're going to treat the direct noise path, and that means sound deadening the wall before installing a floating frame, and then a number of different layers to that frame, which is isolated from the structure. And it's really cool as we're going to show you exactly what we install to that direct noise path. So stay with me to the end of this video and we'll show you exactly what we're going to put on that separating party wall. Next, we're going to treat the indirect noise paths, and that's the areas where the noise can come around. As I said, we're going to remove this wall and we're going to install a solution to the window wall and the other window wall in that room. We've already soundproofed the floor when we did the lounge 2 years ago. We're also going to install sound block board to the ceiling to reflect the noise back into the room to give our homeowner a bit of privacy. As I said, they're hearing every aspect of their neighbours' daily lives. It's making them very aware of what they're doing in their own home.
Alright guys, sorry for the poor audio in that room. When a homeowner clears the room for us, they remove all the soft furnishings, and that produces a lot of echo reverberation in the room, and I could appreciate it must have been quite hard to hear me. I'm back in the studio now, and I thought I'd just go through the 4-step soundproofing method in detail for this project so you can get an idea of what we've installed to the different walls, different noise paths in this room. Okay, so we're starting off with the loft. As I said earlier, that is the main cause of the problem, and there is another main cause that we find when we get stuck into installing the sound insulation. But first of all, the loft is a main cause because it means it doesn't matter what soundproofing you do to this wall, to this conflicting separating party wall or the other areas, if you don't treat that loft, you don't install sound insulation to that loft, the noise will still come through. And that's because the noise from the neighbours next door will go up into their ceiling, up into their loft, sound will resonate, bounce around, it will come down through the ceiling in the loft. So you think that area just above your head, the ceiling, is just plasterboard and loft insulation, it doesn't offer any sound attenuation, and then you've got the single brick wall or double brick wall, whatever your separating party wall is made of. So you do need to do the loft. First of all, what we do to the loft is we brick up any holes in the structure. So go up in the loft, sand and cement. If you can't get sand and cement into all those really difficult to reach areas, then maybe use a sticks-like adhesive, or acoustic sealant is actually quite good, and use bricks, and you can do it more elegantly. Don't use spray foam. Don't just put rock wool in there. Try and put the same mass that's on the separating party wall up there. After you've bricked up all the holes in the structure, there is 2 systems that you can use. First of all, you could apply a 100mm rock rock wool to the gable wall, so 100mm rock wool all up that gable wall, and then come back from the conflicting party wall as well. Don't forget, if you're doing this soundproofing properly, you're probably going to tuck the wall system that you imply down in the bedroom up through the floor. So this board that you see here is the final layer of the TPS 90 I'm going to show you coming up through the bedroom ceiling down below. You would do the loft last. It is one of the first things we're going to mention here in the 4-step soundproofing method. If your neighbours have a loft conversion or something like that, then you need to put something a bit more substantial over the loft gable wall, and I would recommend installing a 20mm rubber. Again, sound deadens that wall, and then apply a 100mm rock wool to that loft gable wall, stopping that noise come through that wall and then down through that ceiling. Because there's quite a big open space in most lofts, that does allow the sound to dissipate quite a bit, using that space to your advantage, which means why you can put that 20mm rubber, then 100mm rock wool, and then 100mm rock wool on the loft floor or the bedroom ceilings. So that's what we do to the loft. Now, as I said earlier, there is another main cause. When we got stuck into this project, what we found is there is actually holes in the structure. Now, we find holes in about 75% of the projects that we go to. Holes are just such a main cause. It means it doesn't matter what soundproofing you do, unless you brick up that hole, the noise is still going to come through. A lot of the time we find holes in the bedroom floors, the lofts, and suspended floor voids, and behind door linings on the older properties. And it's not just old properties, we do find them in new builds as well. So check for holes in the structure as a key area, and as I said earlier, brick them up with sand and cement. Alright, so after we've addressed the main cause of the problem, the next step in the 4-step method is the direct noise path. And here we're talking about the conflicting separating party wall, where noise can come through directly. So here you can see we've already removed the wall, which was not a supporting wall. If we look downstairs, you can see that it was actually on a joist, and you can look here in the bedroom floor, it was actually sat on the floorboard. It made sense to remove this lightweight breeze block wall. Noise travels so easily through a breeze block wall. It was actually more cost effective to remove the wall, and then we're going to show you in a minute how we built a new separating wall between the front and back bedroom. Also note, if you try to install sound insulation to both sides of that breeze block wall, you're going to add a lot of mass to that wall, and you've got to consider the load bearing of that wall if it's not supported by an RSJ. For this wall, it was just supported by a floor joist, so it didn't make sense to add a lot of mass to both sides of that wall. Noise was transmitting down that breeze block wall. When I asked the homeowner to put their finger in one ear and put their ear against that wall, that separating wall between the front and back bedroom, they could clearly hear the TV noise and make out words from the TV from that breeze block wall, because the noise was transmitting so easily through it. If we were to apply sound insulation to both sides of that wall, like a 50mm 2-inch system to both sides, that would have added a lot of mass, a lot of weight. It would have probably bowed the ceiling downstairs. So it made sense to remove that wall and continue the wall system, the direct noise path, on the separating party wall all the way through. And that would be the same case for a stud wall as well. Sometimes it makes sense to go through that stud wall rather than apply sound insulation to it. Anyway, back to the direct noise path, the separating party wall, and here we've installed what we call a TPS 90. So here's the system. We sound deaden the wall, and you hear me say that all the time in my videos. What does it mean? Okay, so here we're installing a 20mm rubber to the separating party wall, and we're applying that rubber, that 20mm rubber. It's like an anti-vibrational matting. We're applying it with two different types of adhesive. The first adhesive, it provides a grab, an instant grab. It's like an industrial style adhesive, and you can find the link in the description down below. It's a non-chlorinated, fire-rated product. It grabs this product to most wall surfaces. You could apply the adhesive to the rubber, and you apply it to the surface you want to bond it to, and as long as it's a clear, non-dusty surface, it will pretty much grab to any brickwork or block work. Then you use another adhesive as well, and this adhesive you don't put on like a dot and dab technique. You don't dollop it. If you ever heard of like a green glue, I'm sure some of you have read up or watched a video on a green glue. A similar sort of technique to that. We're applying it to create a resilient layer, so we get maximum integrity out of this product that we're installing to the party wall. So not only does it sound deaden, we've got that resilient layer behind it as well. Now you might have noticed there is a few mechanical fixings to the black rubber, and that's because we want it to take the load bearing of the next layer. I would recommend installing a few mechanical fixings to the black rubber stage. Again, it depends on what you're bonding it to. The minimum amount of mechanical fixings, the better. It's because we offer a 10-year guarantee with all of our work, just makes sense to put a few mechanical fixings. For this particular layer, and you'll see of all the other layers and everything we do, it doesn't make a noticeable difference to the human ear by putting mechanical fixings, but yes, arguably you will get a better result than if you don't make mechanical fixings. Okay, so the next layer that we apply to the rubber is a foam star insulation board, and it's a honeycomb cardboard structure full of tiny sand particles, so it's a sustainable product. And what we do is we glue this to the rubber in the same methodology, and if you are interested in how we do this, exactly how we do this step by step, you can click the link in the description down below, and we offer a short course on how to install this system to the separating party wall, the small 50mm system. Anyway, this product here we glue with the two different types of adhesive but no mechanical fixings, and you seal up between the joints. Now the theory is that the tiny sand particles in this product, they will vibrate and they will then struggle to transmit their sound energy to the next layer, and the next layer of course is a floating frame. When you install all of these products, make sure you tuck it up and tuck it down. You'll see with this project what we've done is we have joined the system up to the system downstairs. And just on that guys, I would recommend doing the downstairs first. You won't get the full benefit of doing the upstairs until you've done the downstairs. The next layer, you install a frame decoupled from the structure, and here we're going to use the same rubber that we applied to the wall, that 20mm rubber. We're just going to use the offcuts of that as anti-vibrational pads. Now this rubber we use under industrial machinery to reduce that vibration from industrial machinery vibrating through the structure, so it's good enough for my floating frame. We install these as pads on the sole plate and on the top plate. Notice how the wall is not connected to the flanking wall, and this is because that area about a foot from the wall all the way around on the ceiling, the floor and the flanking window walls, about a foot from the wall, the noise will be the same there as it is on the separating party wall. So if you just install a traditional stud frame like this, you've just injected the noise into the frame. You might as well have just connected the frame to that separating party wall. Putting the rubber pads under the sole plate and under the top plate means you can actually create a bit of pressure with the upright studs. Now I would recommend putting mechanical fixings to the top plate and the sole plate. For us, having installed this system for over a decade now, we sometimes use pressure and the anti-vibrational pads, and that is all we need for our frame. After you've built the frame, isolated from the wall all the way around and isolated from the floor, again with the anti-vibrational pads, and isolated from the flanking window walls, install a rock wall, and we use an RW3 rock wall at 60 kg per meter cubed. On some material supplier sites you might have seen where they've installed a rock wall and they haven't insulated the entire frame, or they haven't insulated between the channels in their entirety. Don't do that. Insulate your entire frame completely, and actually insulate under the sole plate and insulate on the top plate as well, where you've put that anti-vibrational pad in. Fill that frame with insulation. Don't install it too tight because you'll compromise it, but make sure every nook and cranny is filled with insulation. The next layer you install is a mass loaded vinyl. Now, as you've probably seen from my other videos, we have been installing this combination of rock wool followed by mass loaded vinyl for over a decade now. It is one of those magic combinations. When you use mass loaded vinyl on its own, if you just applied mass loaded vinyl just to the wall alone, you'll probably get 1 decibel. When you install rock wool just in a frame, it will probably channel the noise into other areas of your property. It forces the sound to change direction. But using this combination of rock wool followed by mass loaded vinyl, we just find that it gives a really good reduction in airborne noise. And the same for that M20AD and the Phone Star insulation board soundboard product. Using that combination just gives a massive reduction in airborne noise. Now I'll show you how to install both of these products in the noise-free DIY soundproofing course. That's our bigger course, which shows you everything you need to do to soundproof your semi-detached or terrace property, everything from materials calculation tools all the way through to electrical plumbing, plastering, skirting, refitting packs. It shows you everything you need to do to soundproof your semi-detached or terrace property. But for the sake of this video, make sure your frame is fully insulated with rock wool, then apply a mass loaded vinyl to the floating frame. Use staples to apply the mass loaded vinyl, and then the next layer is resilient bars. So resilient bars are applied to that mass loaded vinyl. They are going to decouple your finished wall surface from the frame, which is isolated from the structure, and that wall that you've just sound deadened. Now there are many different types of resilient bars, and there are also clip and channel systems. Now I just say that clips and channel systems will outperform most resilient bars, especially in a laboratory setting. We use resilient bars mainly because readily available from most builders merchants. Once you've used resilient bars for the first time, you'll find that they're very easy to use. When you're installing resilient bars, it doesn't matter which way up they go, just make sure that they are isolated a good inch from your flanking walls. We like to hang the top one down from the top plate, and we set the one up from the sole plate, making sure that if a screw was to go through the resilient bar, it's not going to compromise the system. Make sure you draw lines where your upright studs are all the way along, and you can see where your screws and your staples are from the mass loaded vinyl. It's always better to draw lines, and then position the rest of the resilient bars depending on the next few layers that you're going to put and the height of your wall. Everybody's resilient bars, the other resilient bars, are going to be different depending on their height of the wall and what they put on next. Okay, so what do you install to the resilient bars? Now this will depend on your budget and your noise problem. If you're hearing a lot of impact noise, clonking and clanging coming through, furniture moving, then you will reduce that noise by isolation and decoupling, which for the direct noise path of the separating party wall, you've kind of already done by getting to this stage using resilient bars. Arguably, yes, with a clip and channel system, you would get more of a reduction in those lower frequencies, that impact noise, using a clip and channel system than you would do resilient bars. But the majority of the reduction in noise from that impact noise and clonking and clanging is coming from the floating frame and that decoupling of your wall surface from the structure. So if you're hearing gaming, music, low frequency noise like that coming through, then you want to install as many different layers to these resilient bars as you can. So a lot of mass, but as many different layers as you can. The more different layers you can install, the more of those frequencies you're going to reduce, come through the wall and radiate into your room while you're sleeping. Now I'm going to share with you what we've installed on this particular project, and this is not a cost-effective way of soundproofing. It is showing you some of the best products on the market that we've installed to this system to give that homeowner that soundproofing of a detached house. Now the system we've installed to these resilient bars is called a maxi board, and you can find the link in the description down below. We've applied this system to the resilient bars before installing a sound block board. For those of you that have not heard of Maxi Board, it is a product available in the UK. It's a product that we've been using for over a decade now, and it comprises of a cement board layer, which is highly reflective, which is going to reflect the noise back into that lot. It's going to reflect the noise back through that mass loaded vinyl, back through that rock wall, and back through all those layers that we've applied to the separating party wall already. And we've applied the maxi board to the resilient bars just like you install any other board, tucking the system up and tucking the system down. The layer that we apply over the top of the maxi board is a 15mm sound block board. It may look slightly different and the boards look slightly smaller than normal, and that's because this particular homeowner had a very narrow staircase and it was difficult to get the boards up the staircase. We had to cut each board before bringing it up the stairs. I understand not everybody can afford maxi board to be applied to those resilient bars. Just for entertainment purposes, I'm just showing you what we applied to this particular project. You could apply a 15mm sound block board followed by a tech sound followed by a 15mm sound block board. Some people like to use a 19mm plank board followed by a tech sound followed by a 15mm sound block board, or you could just use 2 layers of 15mm sound block board, or you could use a layer of 15mm sound block board followed by a mass loaded vinyl followed by a 15mm sound block board. At this stage, just install a good amount of mass to those resilient bars and then a product which you can plaster, finish your wall with. Don't install one layer of board to the resilient bars, always install 2 layers of 15mm sound block board to the board, and just basic soundproofing principles that you would have seen from other YouTube videos. We like to use a 4mm gap off of the flanking walls whenever we're installing the 15mm sound block board. The 15mm sound block board that we've applied here and the maxi board is tucked up into the loft, and it's tucked down for this case to join the system up with downstairs. But for other projects, make sure you tuck it down, cutting it around joists if that's the case, if your joists are running into the separating party wall. For some of you that do have a joist running parallel, it is so important to tuck the system down that I would go to the extent of removing that joist, tucking the system down, and then putting a new joist in. Okay guys, well that's what we've installed to the direct noise path. There are lots of different systems that you can apply to the direct noise path, so try and take the concepts that I've outlined in this video and then maybe put your own take on it if you're using this video to install a soundproofing installation to your own house if you're suffering from noise from neighbours. Now what we're going to do now is we're going to do the indirect noise paths, and then we're going to do fixtures and fittings. Now the indirect noise paths are such a key component to any soundproofing installation. The reason we get such good reduction in noise is not necessarily because we put such a all singing and dancing wall system on the separating party wall. It's because we do those indirect noise paths, and the more of those indirect noise paths you can address in your own home, the more reduction in noise you will get. Also, before we get into fixtures and fittings as well, fixtures and fittings, before you think about skipping that part, the fixtures and fittings is a key part to any soundproofing project. That is your skirting, your electrical, and they all make up little areas where noise can get through. And if you've got a lot of little areas where noise can get through, that makes up a large area where noise can get through. So make sure you stay tuned to go into fixtures and fittings when we get to that part. Okay, back to the 4-step soundproofing method, and we're looking at indirect noise paths now. We're looking at where those areas where that noise can come around. Now don't get me wrong, we've already talked about the loft, which is an indirect noise path but is a main cause. It's one of those indirect noise paths that's so important, if you don't address it the noise will still come through. But we have got indirect noise paths such as both window walls here and the separating wall, which is going to be put back in to separate the front and back bedroom. There is the bedroom floors as well, which we've already done when we did the lounge, when we did this project a couple of years ago. So I'll just show you what we've done to the bedroom floors, which is what we did to the lounge ceiling down below. So here we can see we've insulated the lounge ceiling, so the whole of the bedroom floors, both these bedrooms are completely mass filled with a rock wall. The next indirect noise path is the window wall. Now what I'm going to do is I'm going to jump back on site now, so you're going to have to put up with my poor audio back in that room, because I want to outline to you why the window frame is so thick. Now, some of you have probably already clocked that. Why are your windows frame so big? And what I'm going to do now is I'll jump back on site and show you or explain to you why we've installed the window frames so thick, and then I'll go through what we've applied to the window walls.
So one thing I really want to show you with this particular project is the windows. You can see how thick the window frame is. We've actually had these windows manufactured to take into consideration the TPS65W, which is our 2-inch system. It comprises of 4 of the most advanced products on the market compacted into 2 inches. And if you want to learn how to install that system, you can click the link in the description down below, and it shows our soundproofing education package, and you can learn how to install that TPS65W yourself to your own home. Now you're probably thinking, why are you doing the window wall? Why do I have to install sound insulation to the window wall? This window wall is actually a key indirect noise path. And this is a test that you can do at home yourself, is to simply put your finger in one ear and put your ear on the window wall. So next time your neighbours are making noise when they're pumping up that music, or maybe you're hearing that lounge TV coming up at an angle, this is a test that you can do right now. Put your finger in one ear and put your ear on the window wall, like that, and listen. See what noise you can hear coming up your window wall. Now what a lot of people do is they test this area here closest to the separating party wall, but they don't test the area the other side of the window wall. They don't go this side and put their finger on there and listen on there, because it's so far away from the separating party wall. Now if you hear the noise on this side of the window wall furthest away from the separating party wall and you hear it on this side of the window wall, then I recommend doing the whole of the window wall with that 50mm system, the 2-inch system. It actually offers 80% reduction in noise on the flanking noise. So it will reduce your flanking noise coming up your window wall by 80%. That's how effective the system is. If you're just hearing the noise here on this section of the window wall, but you're not hearing it on that far end of the window wall, the area furthest away from the separating party wall, then maybe consider just doing this section of the window wall. If you just do up to the first reveal, you no longer need to remove the radiator, skirting, carpet, or plaster the whole of the window wall, and you don't even have to replace the windowsill if you just go up to the first reveal. Now here's an important thing. When you do that ear on the wall test, make sure you test this area here. Finger on it and listen on here, because a lot of properties, they have a cavity wall. And that wall, that cavity wall, is where a lot of sound transmits up that cavity wall. So this area here is a key area, which is why we've had the window manufactured to take into consideration that TPS65, that 50mm system. We can install to the reveal, to the windowsill, to the header, and to the other reveal. This is the one time where you're going to want your neighbours to actually make noise. Our clients here, they have noise from neighbours, they're hearing TV, music, conversation, doors banging, dogs barking, the lot. So here's the test. You want your whole of your house to be quiet, and you want to get it to a time where your neighbours are actually making noise. And you need to put your finger in one ear, so your ear airtight, so this finger's going to go in this ear, airtight so you can't hear anything. Your other ear is going to go airtight against the wall. So here we are, this is the flanking wall, I'm going to put my ear against the wall, airtight without getting a neck ache. And then again on the flanking wall, on the window wall, so I'm going to go over this side here now. Finger in one ear against the wall. Listen on that flanking wall. Now you want to do that for a few minutes to listen, really listen to how much noise is coming down those flanking walls.
And for those of you that have chimney stacks on that separating party wall, again, finger in the ear on that chimney stack, listen, what noises do you hear on those perpendicular areas? Now, if you are hearing the noise down those window walls, on those chimney stacks, on those walls separating front and back bedrooms or separating the lounge and diner, this is what you install to those walls. Depending on how much you hear will depend on how many of these layers you install to those walls. What we recommend to get that soundproofing of a detached house, we recommend installing this TPS65, this 50mm system. Now please make sure you remove any plasterboard or any insulation board from the walls before applying this system. And I know those of you that know me, you hear me say that all the time in my videos, but it is so important. Do not go over the top of a dot and dab plasterboard wall. This TPS65 system offers 50mm space loss. If you have a dot and dab plasterboard wall and you're removing that, that's only a 25mm space loss that you will lose from applying this system to that window wall, for example. Now this system is such an effective little 50mm system that we install it week in, week out. My installation teams install this to separating party walls, to stairwell walls, to anywhere where space is at a premium. You can apply it to any brick or block wall, and you don't need any specialist tools to install this wall. It's very straightforward to install, that most DIYers can install this to their wall, which is why we've outlined exactly how to install this system step by step, with all the glues, adhesive sprays, all the right screws, washers, everything you need, step by step, in a mini course, which you can find the link to that course in the description down below. So if you're a DIYer and you're looking to install something and you don't have much space, maybe even a stairwell wall, because there is a bonus stairwell wall lesson in the offer in the link in the description below this video, click the link in the description. It takes you to a landing page which will outline everything that we feature in that soundproofing mini course. Enough about that. Let's get back to the indirect noise path, step number 3 in the 4-step soundproofing method. And the next indirect noise path I want to talk about is the ceiling. Here we need to add mass to the underside of the joist. Now I know we've already talked about installing rock wool to the loft and the loft gable, reducing the noise coming that way, but remember, noise is in the structure of the building. Now if you're hearing music and gathering with people, you're hearing that noise in every room of your house, that noise is transmitting through the structure of your building. And the ceiling joist is an area where noise is transmitting through that wooden joist and then radiating into the room above your head. So what we do here is we add mass to the underside of the joist. We're installing 15mm sound block board to those joists, and I would go over the top of any ceiling board. Going over the top will give you more fire rating, or and it would add more thermal value to the room. It reduce the heat escape in that room. So go over the top of the existing ceiling. 15mm sound block board with a 3mm plaster skim is 18mm space loss to the ceiling. It's something that I recommend, especially because it reflects your noise back into the room. It gives you your privacy as well.
A little tip when you're boarding your ceilings: once you offer a board up here, you're not going to see where this channel is running. So as you can see, because it's a dark beam, we've put a bit of masking tape and we've marked the locations of those, meaning when we offer a piece of board onto here, we've still got where the channel is sat. So we can mark that and draw a pencil line, so we ensure that we fix into the right place without missing. So like we've done on this board here, we've marked the lines through, and then we've put 5 fixings across the board, obviously 1 each end, 1 in the middle and 1 in between, nice and evenly spaced. The boards have got these little X's to signify half a board anyway, so you know when you're pretty much bang on the middle there. And then our next sheet that we offer up, we are going to stagger from this. So we're going to use this edge as a datum to work along, and our next board's going to come past here and stagger back to a certain point.
Another indirect noise path for this particular project is the separating wall between this front and back bedroom. Remember, we removed the wall at the beginning and now we need to reinstall another wall. And here we're not going to use a traditional stud frame. We're going to decouple the wall from the wall, the new soundproof wall. We're going to use anti-vibrational pads. So the sole plate is on anti-vibrational pads. The top plate is on anti-vibrational pads. We've used a 4x2 timber for the sole plate and the top plate. And then we've used 3x2s and we've set them back from the wall that we're applying the SoundBlock 15 to. We've offset the timbers and we've used 2 layers of SoundBlock board on each side of this stud frame. Setting the upright stud frames back and then adding more studs than you would normally, but setting them back, it does help a little bit with the higher frequencies. It was something you do especially if you haven't got space for resilient bars. Okay, finally the fixtures and fittings. Step number 4 in the 4-step soundproofing method. Fixtures and fittings are a key part of any soundproofing project. They are little areas where noise can get in, and when you have a lot of little areas, they make up a large area. So things like a plug socket, we know from testing that a socket, when you cut a great big hole in the wall for a socket, you don't put the same soundproofing materials behind the socket as you've done on the rest of the wall system, then that will let in maybe 3 to 5 decibels of noise. It is an area which you have to address. You have to put the same materials that you're putting on the wall behind the socket, and there isn't any acoustic putty or anything like that that's going to offer the same sound attenuation as a 15mm soundblock board or a cement board, fibre board, different type of barrier mat. You've put in all of those layers on your wall system. You wouldn't then just cut a great big hole in the wall. So make sure you put the same materials that you apply to the wall behind the socket. Things like skirting, make sure it's isolated from the wall. So we like to use a 4mm packer, isolating the skirting from the wall. If you think how much sound is transmitting through the floor, we don't want that to vibrate through the skirting. We also want that wall to vibrate. You know, we've made all those decoupling and we've put those resilient layers in place and we've isolated the frame from the structure. We don't want to then compromise it at that final layer by fixing the skirting to the bottom of the wall and then fix that to the floor. So make sure your skirting is decoupled from the floor. We don't install any coving because the coving will channel the noise around the room. Install carpet or as many soft furnishings as you can to reduce the echo reverberation in the room, and that will stop the sound bouncing around in the room. I don't evaluate any soundproofing project until at least 4 weeks after the actual installation, till the homeowner has installed carpet and they've moved back into the room. With things like radiators, again, make sure that the brackets are fixed back on the wall without compromising the system. You can just go bypass the system, go straight through to the brickwork behind, but make sure if you're using these products that I've outlined on this video or on the mini course, make sure that loads of sand doesn't come out. When it comes to the fixtures and fittings around the window, such as the windowsill and the other parts where the TPS65 50mm system will return into the window, we've not had a case where the TPS65W, the 50mm system, doesn't fit a window. There are lots of clever things you can do with UPVC and reducing the amount of layers and all those different types of things, which we outline in the mini course. But as I said earlier, it's very important to do that area over the cavity and that header area, because a lot of people have cavity walls and a lot of people have rigid insulation in their cavity walls nowadays. So really reducing the noise on this area, the window reveal, is very important. And I would say do whatever you can to get that 50mm system onto these window reveals. If you live near a busy road or you have noisy neighbours and they like to socialise out in their garden and that noise is coming in affecting your sleep, returning the 65W into the window by doing the window reveals, the header and the windowsill, you will improve the integrity of your windows. If you're suffering from outside noise and noise getting in through the windows, then you might want to check out some of my other videos on road traffic noise. I wish I could install this method to every home with a noise problem, but it's just not practical for every home from a space point of view, and not everybody has a budget for these types of materials. However, I hope you can take away some of the concepts I've outlined in this video and reduce the noise for you and your family. Now, 94% of you that frequently watch my videos don't subscribe to the channel. So I would kindly ask, if you've ever enjoyed watching any of my videos, please click the subscribe button, because it helps the channel more than you know. The bigger the channel gets, the more of these videos I can produce and help you reduce the noise for you and your family. Maybe consider bookmarking this video, adding it to your favorites. There's a lot of information in this video and it might be something you want to keep referring back to and having a look at how we've done things. If you've not got yourself a free e-copy of the Noise-Free Home, click the link in the description and get yourself a free copy. This is not a textbook, it's not a how-to guide, it's a book for homeowners which goes through the 4-step soundproofing method to help you reduce the noise in your home. If you really want to learn exactly how to install soundproofing like this, my team and I teach this. Maybe you're a builder and you want to install sound insulation like this to your customers' homes, or maybe you're a DIYer and you want to reduce the noise from neighbours getting into your home to reduce the noise for you and your family, then why not learn from award-winning soundproofing installers? Soundproofing installers that have installed sound insulation to thousands of homes across the UK and want to show you exactly how you can reduce the noise in your own home. The link for both of these courses is in the description down below. I hope you enjoyed this video. I would love to hear what you think and any questions that you have in the comments down below. And if there's any part of soundproofing that you would like me to do a video on, then please put that in the comments down below as well.